Ooh. All right. I'm sorry, I'm incredibly late today. 6 whole minutes. Why does my bitrate say offline but I'm online? That is interesting. Anyways. To let my mod know that I'm streaming. Oh, shoot. Let me quickly switch the scene so I can log into the other machine. Yeah, it should have all been done before, but yeah. Right. Oh dear. Morning, Kakalangjo. I'm incredibly late today. I haven't even started up my PC or anything. As you can see, like there's a bunch of stuff happening here. We've been restructuring the room and things like that, so it's all a bit chaotic at the moment. All right. Okay. Let me add Ko-fi stuff. Ko-fi.com. Yes, I want this. And we're gonna paste that in here. Maybe with the right keyboard shortcut, that would be ideal. Okay, actually, no, hang on. Source code available at. That's what I wanted to write. Morning IO means live. What do you mean unable to pin? Oh my gosh. Let me refresh the tab then. Oh, it pinned, but it said unable to pin. I don't understand software sometimes. How is everyone this morning? If it is morning in your area, I don't know. Okay. Right, let's go to the PC. Can't complain? Nice. What more do you want, right? If you can't complain, that's a good thing. In my books, anyways. Okay, let me move this one over here. My desk is also a bit chaotic because I have been setting up a server. A home server, that is. And you see it on the screen right now. That is my own Gitty installation. So I made this whole little thing. This is running on my own home server, and this is where all the source code will be stored. And it comes with all the nice things that GitHub has as well. So I can do like, look at individual commits, see what changed, in which line it changed, all this kind of good stuff. And eventually, for Ko-fi supporters, I want to make some of these public. I have to kind of figure out how to do it, because at the moment it's only available on the home network, right? There's a few challenges with making it available publicly, especially like with HTTPS and all this kind of stuff, right? I kind of need to figure it out. Obviously dynamic DNS, because I don't have a static IP address. So all this kind of stuff. But hey, we can also see that the Git part here is only taking 125 kilobits for this whole project, which is nice. I think Jonathan Blow is missing things like graphs and charts in self-hosted solutions. What kind of graphs do you mean? I mean, let me put it this way. This whole thing is open source, so if you really need something, you could always try and figure out if someone else has already provided a solution for this, right? And then just implement it, or you implement it yourself. At the moment, I'm just happy that I have something like Git, right? Because my previous version control was literally just, let's go in here, right? Projects. Oops, there's alpha 4 in here, which is not supposed to be in here. But I literally just copy pasted the code into a new folder and was like, okay, this is going to be my new version, right? Which is, you know, it's not a bad way of doing it. And then you can like compare with like WinMerge of what's happening and stuff like that. But I was just a bit worried that it's all on my local machine and I wanted a way to have like a backup. This is why I have now a home server, which is like somewhere else in the house, essentially. I still need to write a backup script for this one, so periodically dump this whole Git installation into a zip file and then, you know, copy it somewhere else. I want at least 3 copies of everything, so... But yeah. What I like, it also has an issue tracker and stuff like that, so I will be utilizing that, probably. Yeah, pull requests don't make sense at the moment, right? It's my own code base. I'm just going to be... I don't need to make pull requests or anything like that. But yeah, I've also already plugged in all the releases, so Alpha 1, 2, and 3 are in here, right? And then we have Alpha 4 at the moment, right? This is the latest commit, which is all the changes that I did on the 8th and 10th of April. But I haven't released that as an alpha version yet. I still want to do a few more things before I do that, and this is what I'm going to do today. I will get to it, what I want to do in a moment. Another thing is I haven't released a YouTube video yet. I promised to do one every Friday, but it seems I'm going to miss. So I missed last Friday because I wasn't feeling that well. And I'm also going to miss next Friday because I'm going to go on holiday. So that also means there won't be a stream on Wednesday. I usually stream Mondays and Wednesdays. And this Wednesday needs to fall flat because, well, I'm going to be out of town, essentially. But maybe I can stream on Friday evening and the weekend just to make up for that. So there is at least 2 streams this week. I have to think about it, but I won't be able to do the YouTube videos. There's just no chance. They take a lot more work than just streaming, right? So I won't be able to do that. Okay. Right, so I have only 4 commits at the moment because like those are all the changes that I did at once, right? I haven't been using Git or anything like that before. From now on, I will probably do smaller commits and then just make Alpha 4 like a tag, like these releases, but like it's going to be a collection of smaller commits essentially. It's probably a bit overkill for a project like this, but whatever. Okay, what is this? This is the wrong thing. Actually, hang on. Do I need to zoom in a bit for the stream? That's probably better, right? Something like this. Okay, and then here Let's open up all projects. Okay, here I was thinking about something, but I need to probably zoom in as well. Let's make 18. 18 sounds nice. Okay. So I'm not sure if I already talked about this. I've changed the build script a little bit. GB assembler, right? Oh, so now I can do git status and all this kind of nice stuff, right? But I changed the build script, so I no longer have a separate run or debug script. It's all within one bat file now, so I can just say build, release, and then run it, right? And it will do that. I can say build, release, run, debug, right? And this will automatically build, start the debugger, and then I'm going to be able to step through my code if I need to, right? I'm not sure why I started the release version, but here we are. God, why does it open so many tabs? Come on. Right. Okay, so I had this crude to-do file. Sorry, finishing my coffee. And preparing a glass of water. Which is your reminder to stay hydrated. Drink some water. All right. So I wanted to do a bunch of code cleanup, but I didn't want to do this on stream, right? And I haven't done this off stream because really, this last week was just rough on me. I don't know. I really, yeah, no motivation whatsoever. Absolutely crashed. But I wanted to look at the tokenizer. There's a few things that we can... Okay, so my overall goal for today is to start building the parsing blocks, right? That we then combine together to have like an abstract syntax tree. And for that, I need to do a few changes on the tokens, on the tokenizer itself. For one, I need to have more fine-grained tokens. And another thing is, I thought about this a little bit, and there's some tokens that just don't make sense to even propagate to the parsing, and that is whitespace and comments. Now, whitespace, it's useful to know, right? Because those are like a logical separation of your tokens. So whenever you encounter a whitespace, it means whatever comes after it is a separate token, right? But then when you're doing the parsing thing, you don't want to have constantly code that is like, oh, if the next token is a whitespace token, then skip it, right? Because then you have to do this like in every single parsing thing. What would be better is if the tokenizer itself just ignores those, right? It just doesn't even pass them on, because why would it need to? We don't care about those. Those tokens are more useful if you actually want to build, like, I don't know why you would need those, to be honest. Maybe if you want to do code generation out of it or something, but so you can put like white spaces on the right place or whatever. I mean, it becomes useful if you have a language that is white space dependent, right? So there are some languages where the amount of white spaces that you type actually do something specific for the code. I can't remember which ones, to be honest. Actually, maybe let's just Google it. Wait, there's a programming language called whitespace? I mean, of course there is. Well, there you go. In a language like that, whitespace would be very important, right? Because you're programming in whitespace. Who the hell thought of that? That's hilarious. Oh my god. Oh my god. yeah. I'm sure there's some other programming languages where white space is kind of significant, but in this assembler, definitely isn't. So we can just skip it. What we do want to get, though, is new line tokens, because, you know, they're an indication for the parser that this line is done. And we should stop parsing, because we're only parsing line by line. Yeah, that looks like pain, doesn't it? Okay, so we definitely want new line. We do not want white space or comments. So I could now try and change this tokenizer to ignore them whenever we have read token, right? Or whenever I advance and call read token, and if I get a white space back, I'm just going to call read token again. Because there's no chance that I get two white spaces, but I might get a white space and a comment and then another white space. No, actually, I only can get a white space and then a comment token. Yeah. So I don't want to do this, because then this would have to call itself, or I have to integrate like an awkward loop in here, which just overcomplicates this code right here. And I don't want to do that, right? Because this is kind of very concise, and I want to keep it that way. So what I'm going to do is on read token, we can do something like this. Read token excluding white space. There we go. Right. And then we can just do a do while loop here. And what we say is, well, read our token from this file, put it in this token. And while this token type is token type white space, or token type comment. Then we call this again. And on anything else, we just stop. And then we can just call this here and here, right? So we're reading the current token, excluding white spaces and comments. And then down here, we just call that one as well. And this function is so small, it will probably be inlined anyways. So it effectively just becomes a loop. We could have an assert in here, that is fine. File is not null, and token is not null. Okay. So now here, we no longer need to check for white space or for comment, because we are no longer receiving those. Let's check, build and run. Wait, do I have to, yeah, let's enable the invalid token thing. I do no longer have get token string, but what I have is, I believe I added token text. Yes. Nice. So what we can do is make this a dot percentage token. Oh, I have a macro for this, if I remember correctly. String to format arguments. There we go. And this will be token text. Sorry, build and run. Interesting. The empty one might be actually the comma, because I'm not filling up the text for commas. And this seems like, because there's a lot of hexadecimal numbers, so it might just be the comma. Where's separator? Yeah, it might just be this one, because I'm not filling up token text there. Length is 0. Yeah. That is okay. Right, so here. So alias, RBGP, and then line 7, column 12. Yeah, there you go. So that is the comma token. And then we have this. And then line 8. Invalid token. Right, this one. Okay. That makes all sense. Okay, so now, because this is Git, right, I can actually do a commit for that. Why not? Git status, right, git add -u. We want to add all the changes for the files that have been tracked. Git commit. What will be our message? Tokenizer now ignores white space and comments. We can push it to my home server and it says authentication failed, which for some reason the first time always happens. I don't know why. But on the second time it just works. We can make sure that it works, just refreshing, and we have here our commit. And if we now want to look at that commit, we can do that by just doing this, and then you can see all the changes that have been done, which is quite neat. Again, you could use GitHub for that, but I do not want my code to be public, nor do I want some stupid AI to be trained on my code, right? So here we are. Okay. So this helps us a little bit with the parsing. Now, I want to sort of build the building blocks for the parsing stuff. That means parsing all the little components that can happen, right? So this includes names, this includes operations, this includes binary operators, right? I want to have plus, minus, divided, times, whatever, you know. And also braces and all this kind of stuff, which means I also need to add a few more tokens here and make those a bit more fine-grained. Okay, yeah, let's start with that then. Let's think about the tokens that we actually want. So white space and common are still in there. It's useful to have them, right? As we just saw in the code down here. Even though we ignore them, it makes the parsing a bit more straightforward if we just pass those as tokens, but then completely ignore them. But yeah. So what do we want? Let's make a list. So we want plus, minus, division, right? Times. Do we have an equal sign? No, we don't. We have braces, open and close braces. And those mean different things depending on contexts. Actually. No, I will use different braces for that. So I was thinking of indirection, you know, usually indirection is used with these braces, but I'm gonna use square brackets like that. Sorry, I call those braces parentheses. Okay, then we have, to indicate a string, we have one of these. Then we have, let me see, I already have a few ones in here, right? Right, we have the comma itself, right? So let's do it this way. We have a semicolon. Indirect will no longer happen like this. Right, we have hexadecimal. We have percentage for binary. We have this for a label. We have this for a directive. And what else? I don't want to have prefixes or postfixes or that kind of nonsense, right? We could have or and and, so like binary operators, right? That would be useful, actually. Maybe XOR and not. We could think about shift. And also plus and minus here mean different things, right? Depending on context. So it either is a binary operator or it is a prefix for a number, right? If you have a negative number, it's going to be this. But we can figure that out already with the tokens as a number token, actually. Because you want numbers right after it, right? If it's a negative number. Although, no, you can't, because it has to be something like this. Yeah. Can't do that because you can also write it without a space, right? Or like this. And this would then become an operation. All right. This is the first time I'm writing something like this, so I'm sure I will get it wrong. Okay. Okay, let's make the fines for that. So the fine token CP plus fine. Actually, I'm really questioning what those defines actually buy me. Except make the code a bit more unreadable, but we'll see. Minus, this is gonna be this one. Right. Token CP divide. Am I getting the dog? I'm getting the dog. Yay. Hello. Hi. 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 Do you wanna say hello? Hello. 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 Okay. Do you want to help me program? No, you just want to sleep. Well, that's a bit lazy, isn't it? Okay, I'll put you on my lap. How about that? There we go. You're gonna be my rubber duck. Is that alright? So if you hear any weird sounds, it is my dog. Okay. Right. Okay, we have define token CP multiply actually getting tired of typing this. Open square and then close square. Okay, we have this as a string, but let's call this quotation. Comma and semicolon. We don't have indirect anymore. We just have multiply. Okay, so we got these out of the way. We got quotation out of the way. Oops. Quotation. We got the comma out of the way. We got this out of the way. Okay, then we have hexadecimal and binary. That is still okay. Doesn't matter what those mean at the moment, so I'm just gonna do that. Label, directive. I think the idea for this was that if I wanted to change, for example, the token for a label, I can just do it here without having to change the code, but I'm really questioning if those defines are even useful. You know what? Let's do it without those. And see what happens. Okay, so this will become only this. Right. So is code point token is basically just checking whether it is one of these known tokens. So we can just plug them in here, right? So we can just do this and then say, well, we want a case for plus, right? We want a case for minus. We want a case for this one, for multiplication. Let's keep the code simple. Case for this. Then one for this one. Then the comma, right? Then the semicolon. This thing and this one. This one. Come on. Case. Bang. Okay, this one right here. XOR, fine. This one. This one. And this one. Okay, I had common separator indirect. Yeah. Okay, cool. There we go. We can probably simplify this if we looked at the ASCII table, right? Table. ASCII.com, sure. There's the pound sign. Do we need pound for anything? Single quote could be used for a character. Do we ever need characters? I mean, it would be useful if we can just add a single character and get like the hexadecimal number for it. It's probably useful to have. A dot. Do I need a period for anything? Probably not. So what I was thinking is instead of like all these case labels, you can probably just say if this character is between this range, it is a token, and if it is between this range, it is a token. But I see like there's already some of the things that I don't utilize at the moment, so. And then some of these are way down here. Yeah, let's not. Yeah, that would make just things too complicated. Okay, let's just leave it like this. Okay, read whitespace sequence. That is still pretty straightforward. This will stay the same. Read end of token. We have is code point token, which we just changed, so this will just be the same as well. Cool. Read end of line. This is also the same. Okay, read end of string. I have to think about it, but okay, end of file, new line, white space. All of this stays the same. If we have a digit, right? So whenever we encounter a digit, it will interpret it as a number. Even if there's some gobbledygook afterwards, it will be a number, which is all right. So we're gonna read end of the token, set this as the text length, and report a number. Perfectly fine to do. Now, a comment, right? So a comment needs to do a bit more work. That is okay. We just read until the very end of the line. Oh, you want to go to the bed now? Okay, there you go. Enjoy. I'm free. Right, sorry, I've been touching the microphone. It's probably a very annoying sound. Well, comment is just... All right, these are... Okay, I have to kind of change these to these ones right here, right? Which is okay. Let's just get rid of this. And we no longer need this. Okay. So this has nothing to do with precedence and all this kind of stuff yet, right? We're just trying to figure out the tokens and trying to build the tokens out of it. That's basically all that's going to happen. So we know that we use this character right here as a comment, right? So really, we're just going to have this code right here. Because what we want to do is we set the token type to a comment and read to the end of the line. Cool. Now, a separator token, which is the comma, is just that, right? It is a separator. So like that. What, now you want to go out of the room? 1 second. All right, okay. There you go, mademoiselle. See you later. Don't be a stranger. Okay. Dog is out of the room. So another thing I'm wondering is for these tokens that are just a single character, I can just give it the ASCII value, right? So let's look at all the single ones, right? So we have token type plus minus. And we can just say your value is gonna be, well, plus. And your value is gonna be minus. Token, not roken. Token type divide. Oh my lord. I can't type today. I don't know what it is. I can't type. Token type multiply. Right. Braces, I probably, so parentheses and stuff, I probably want to report separately as well. I do not want to combine them in the tokenizer. That is part of the parser. Yeah. So token type wait. Okay, comma. Can be separate as well. Actually, no, semicolon we don't need because that indicates a comment, right? And we already have a token type for a comment, so this is like a more complex token, so we don't need to worry about this one. These are not complex token, those are simple tokens, right? They only have one value. Now, all of these, like the quotation marks, that is a string, that is a more complex token. A hexadecimal number is also a more complex token, right? A binary number is a more complex token. A label definition with this, also a more complex token. The bang, that would be for directives, usually followed by a name, so also a more complex token, right? So these might be a bit more simple again. So we have token type, let's call this or, right? Token type and token type not or negate or whatever. And these are more complex again, because those actually have two characters, right? So we cannot just simply give it the token type of this. Okay, so separator we no longer need. Keyword we do need. Label, yes, we do need. Indirection, nope. Number, yes. Directive, yes. That will be the bang character, right? So that's going to be a directive. An identifier is anything else. Then we have a string. Now token type number. We should call this decimal. And then we also have token type hexadecimal, token type binary, right? Okay, so we have string, we have binary, hexadecimal, we have binary. This is a label. This is a directive. Okay, so, and now token type left shift, token type right shift. We can be a bit cheeky and just give it the value for this, I suppose. Even though they use two of them. Okay, here I have to be a bit careful. What is the lowest? That will be the vertical bar. No, the tilde. Okay, so we want this to be the last one. So every one of these then... I mean... I could just do this one, right? What is the last thing? It's delete, which is not allowed, so we can actually use 0x7f, whatever, and then go on from there. Yeah, whatever. And these go from 0 to... yeah. Okay. Okay, so these are all the possible token types. These have single values. So, right, let's just plug them in here. And I mean, these values are just helpful to then print, you know, the token as a character out into an error message. So if I ever have an error of like, hey, invalid token separator found, right, then I can just print out this thing. And if it is a bit one of the more complex ones, I can just say, well, just printed the text message, right? Okay, so is code born digit? I renamed this not to number, but to be decimal, right? So we just not have a generic number type. We actually have a bit more, you know, a bit more fine-grained tokens. Let's put it this way. You can have just one number token, and then just allow anything in there, which is fine. But for example, let's say I have a jump instruction, right? I maybe don't want to allow binary numbers or decimal numbers in there and just use hexadecimal because, well, addresses are kind of easier to reason about in hexadecimal numbers. And you do not have to worry about, like, in decimal numbers, you can have a minus prefix, right? So it could be a negative number. Then you need to figure out, okay, how do you encode that negative number into an valid address? And it's just confusing. So we might just disallow on jump instructions to use decimals altogether. And binary is just, yeah, who would want to encode an address in binary while you're writing out the assembly, right? So that way we can restrict it a little bit if we would like to, I suppose. I'm not sure if that's useful yet or not, but we'll see. Okay. Okay, so this would be comma, right? And then this would be token type plus. Then we have, you know what, let's just copy this all the time. Token type minus, right? This would be token type divide, multiply, open para, close para, open square, okay. These are more complex ones. So we're going to push them down. And then this one is or and XOR, and let's call it not. Okay, and actually I also kind of want this one. That would be token type character. I mean, honestly, it doesn't matter what kind of numbers you pass in here, right? I could actually do that. Right? Doesn't really matter. Right. Like comment could be this one. White space, you could just have literal white space. New line could be new line, right? Yeah, whatever. These numbers are arbitrary anyways. But it helps to associate them in my mind. So, okay, so these are all more complex things, right? So these all need to do a little bit more parsing, or rather reading of the tokens, than any of these. Like, these are just single ones, right? I mean, you could put this in one line if you would like to reduce, your line numbers in your code, right? You could do it this way. I mean, just whatever is more readable to you. It doesn't really matter. Maybe I changed that, but let's not worry about this now. Okay, so the less than, right? So what we want to do here is basically get the next code point. I'm just trying to think now. There's a lot of characters that I could use in names, which are now allowed. Like, for example, the grave accent would be allowed in a name, because it's not being treated as a token. You could use @ in a name. You could use question marks in a name. It is a bit weird. Or the equal sign, right? So maybe I can use all those unused characters and have something like an invalid token. Because those are not allowed. Right, that way we can report an error message saying if we ever encounter this, hey, there's an invalid token. Like, what are you doing there? And that would be any other of these. But then we also don't go into the extended set and all this kind of stuff. And we allow Unicode characters anyways. Maybe it's just not a worry. Maybe I just shouldn't worry about this. I'll definitely want this though. For the same reason, if like the shift has only one character, then that is invalid, right? So I want to report invalid. Anyways, so I'm getting the next code point, and we have code point already defined up there, right? So actually, let's call it next, right? So we're getting the next code point. If next is this little fella right here, then we have a left shift, right? So we can then say token type equals token type left shift. And we want to swallow that code point. Oh, I just say file and code point. Okay. I have to remember how to do this. Okay. If it is anything else, we do not swallow the next code point because it might be a different token, right? But we want to report an error for this one, so probably what we're going to do is token type is token type invalid, right? And we want to say and this one, right? I might be overcomplicating this a little bit. I was just thinking maybe I could just use the ASCII values in general for the type, and then so instead of having token type invalid, I could just do this. And that would result in a token type that is basically unknown because we have not assigned this anywhere. Right? Let's do this one directly. No, because I'm assigning that here, right? Ugh. Okay, let's not overthink it. Right. So, basically, look for a less than sign, right? Get the next code point after it. Check that it is exactly the same. If it is, we have a left shift because it's 2 characters for that one, right? And then we want to swallow that code point. We could probably... Actually, we need to do this for both times, so let's just do that. The only difference is whether we swallow that code point or not. And here we want to have token type invalid, right? Okay. We need to do the same thing for greater than. All right, so we can just copy this and just say greater than. And then it becomes a right shift. Okay. I forgot to add some here, didn't I? Yeah. Okay. That was token type left and right shift. And now we can do labels. So label is a bit special, right? Because we're already checking when we have any other character, it is a symbol name, right? A symbol name could either be a keyword or like, a variable or whatever, or it could also be like a label definition. So when we read an identifier like this, we already check for the token right here, right? Yeah, we already checked for the colon at the end, and then if it has one, then it becomes a label definition. So this instance is just if you have it empty somewhere, right? So there is no characters in front of it. So instead of having foo, which would be the label foo, right, you just have something like this, or a bunch of white space in front. Or you have foo, and then followed by a bunch of white space, and then this one, right? That obviously is wrong. So this is essentially an empty label, and we already had that. Oh, just like that, token type label. Okay then. Fine by me, fine by me. So this is actually one of the simpler ones. Okay, never mind. Let's put it up there together with the other simpler ones. All right. Right. Hexadecimal. This becomes token type equals token type hexadecimal. And we need to find the whole sequence after it. So what we can just do is read end of token, right? And then whatever we have at the end of it is the length. So the length could turn out to be 0. And then it just becomes an invalid hexadecimal, right? When we go to the parsing stage of how to parse hexadecimals, we can then say, hey, what the hell are you doing? This is wrong. The same goes for binary, right? Exact same code. And actually the same goes for directive as well. Token type directive. Read end of token. It's just a bunch of text. Okay, so read string goes to the end of string, right? So it looks for the end quotation mark. But we're not validating whether the string is actually closed or not. We're just trying our best to read it that way, right? So just put that here. Okay, and then this one is just reading a single character. So this would be token type character, and we also want to do this at the end, but we need to verify like the next 3 tokens, right? So if probably want this to be a separate function, to be honest. It will be inlined anyways, because this one will be quite small, but read end of character, right? So we're getting the next code point, and if it is not end of file, and it is not a new line, no, we don't want to do that. That is... Whoops. Okay, let's use this range right here for valid characters. Except this slash and this one right here. What is end of file? End of file is just 0. Fine. So if count point is 0, if count point is smaller than 0x20, then we just return. And if code point is or it is bigger than 7e. So this is the valid ASCII range for a character, right? Now, if code point is this one right here, then we treat it as actually, whatever we have here, we want to swallow that count point, right? because that is going to become a valid character. And if that valid character is or happens to be this one, then so this would be in a situation like this. So an empty character, that essentially closes like the character for us, right? So we're no longer parsing, so we're going to return. That is the end of the character. However, if code point is a slash, then we might want to do something. What do we want to recognize? So we can recognize /t for tab, /n for new line, // for slash, right? Or we can have this. We don't need that one because, you know, well, we can do, I guess. Okay, switch code point case. So we have t, we have n, and we have a slash, or we have one of these. I mean, we can just, why not? If it is any of these, we just swallow the code point. And move on. Hang on, do I need to do validation right here? That seems like something I have to do later. In the parsing stage. Really, I'm just looking for the end, right? And I know if there's a slash, then there is one character after it, whatever it might be, right? So, I mean, what we probably want to do is we don't care what it is. We just swallow it. Right? So we're countering a slash. We just check the next character, and whatever it is, we just take it. Done. And then after that, so hang on, we swallow this one. If it is that, we're done. If it is that, we just swallow the next one. And whatever happens from now on, right? When we reach this stage, we already have some kind of character in there, right? So we have something like this or this, right? Or we have a slash with some character after it. We don't care what it is. So now we're just looking for the end quote, basically. So if code point is an end quote, then we can swallow that code point. and return, right? If it is not a code point, it might be a different token, but our job is done, right? Because, well, it probably is a wrong token or something, or something else does. Either way, this will be reported in the parsing stage as an invalid character value, right? And whatever happens after it, so for example, if there's like this happening now, this might be reported as a valid token, sure, but like we know this will be wrong, right? So in any way, we do not need to return, we just need to swallow it if it is like a valid end. If it is an invalid end, we don't swallow it and give it to the parser again for the next token, right? Yeah. Sounds about right. Okay. So this will become read end of character. And then we have the default stage, which is anything else, right? So we're just going to read the end of the token. And then we check the last code point after this. And if it is one of these label thingies, then it becomes a token type label. And we swallow that code point as well. I'm questioning whether length 0 makes sense for all of these. I have to think about that a little bit. But okay. Otherwise, we have this hash map table, right? So the global keyword table, where we just take the token to figure out whether it is a keyword or not. And if it is a keyword, we're just going to return that. If it is not a keyword, it is just an identifier that we will deal with later, right? So it might refer to a label, or it might refer to a constant, or something else. Okay. Now, does length 0 make sense? Probably because none of these have a value, right? Or rather, we don't care about the value. All right, let's put this all in one line. And while I'm putting them all in one line, I'm just going to think about whether I need to adjust the length a little bit on any of these, but not so far. No, also not on this one. XOR, nope, definitely not. Nope. Damn it. Label if it is an empty label, we leave the text as length of 0, which makes sense. So that way we can actually verify if that the label is empty. So that makes sense. Here, I don't like this token invalid part here. That is the only time I'm doing that. I'll probably move those into the default arm. I will explain why in a bit. Because I don't like this invalid nonsense. Okay, then we have hexadecimal. Read end of token, read end of token, read end of token. We have string, which reads to the end of the string. And this reads to end of character. And the length is adjusted on all of these. Okay. But this includes that character for the length. Ah. Good thing we went through it. So this can be omitted from the value, right? Because this is just the prefix. So I actually don't want this. So what I'm probably going to do is say token position. Hang on, what does read end of token do? Read end of token just gets the next code point. I can call this twice in a row and it will still get the same code point. It only advances if I call swallow code point, right? So should I just leave the prefix in there? I mean, I leave the surrounding quotation marks in there. I might as well just leave the prefix in there. It's just a bit annoying because now I kind of have this difference because for label definitions, I don't leave the colon at the end there. So but that's okay. Okay, no, I'll leave it as is. So now why I moved this down a little bit is because I probably want to put them in here. Because if we don't have two of these characters like this to indicate a shift, like or left or right shift, it might just be part of a name. So A, B, C, D, right? I know this looks absolutely nonsensical weird, but because of the rules I have, this would be a valid name, right? Because, like, also this, no, not this, but this would be a valid name. So And I don't want to give too many restrictions on label names. That is also my issue. Because I allow a lot of UTF-8, formatted strings, so... And I don't want to figure out what's valid in Chinese or Indian or whatever, right? To use for a name. That's why I have like very lax rules. So... But these also count as tokens. So if I say read end of token, if I reach one of these, I'm stopping. Which is probably not correct then. Where's read end of token? So is code point token. Checks for this. No, I need to leave invalid in there. I don't see another way of doing this right now. If anyone has any suggestions, let me know, but I'm a bit dense right now. I mean, in a different programming language, right? This would be... I wouldn't have this issue because this would then be just seen as greater as and, smaller than and greater than, basically. But I do not support these for an assembler, and I don't think it makes sense to support them because we don't have if statements or anything like that, right? Yeah, that's Alexa. I just call it tokenizer, but yeah. Well, then you're right on the money here. Except we don't write compilers, but an assembler. A bit simpler than a compiler. You don't need to worry about optimizations or anything like that, and just parsing one line by line. But yeah. Nice. Which book on interpreters are you reading? Is it the one from Nystrom? Crafting Interpreters, or what's it called? This one. Yeah, Crafting Interpreters. Yeah, that's what most people go for, isn't it? Yeah, I haven't looked too closely at this one. I kind of want to try and figure things out for myself at the moment before I look into this stuff. So, but yeah. I heard from a lot of people that it's all right. So, I mean, yeah, let's just leave this as invalid. I just have these characters as invalid. I might just decide to add some of the other characters as invalid later on. So I'm just going to leave it like that for now. You wrote a program in straight bytecode. Jesus, why would you want to do that? Yeah, that sounds horrific. Yeah, so I essentially want to, you know, write stuff for the Game Boy just to learn a bit like low level assembly and things like that to get a bit more comfortable with that. But I also thought it would be fun to actually figure out how to write development tools because I was always interested in kind of how they work and how I would be able to write something like that I use on a daily basis. So I was like, okay, let's just write the assembler ourselves and then learn how to write assembly and all this kind of stuff. So okay, I think this is all that's needed for now. Oh. Mistake. I forgot the brakes. That would have been fun. Would have fallen through. Oh, dear Lord. Break, and... Well, it's the last statement, but I don't really need to break there, but there you go. If anything, put it in here. Okay, so... Right. Token H. Nope. What am I doing? All right. Sorry about that. It's not a define label, is it? Okay. 3-4. Also not a constant. Jeez. Okay. Get code point. Too many actual parameters. What? In line 92. Right. That would be correct. Token type XOR. Undeclared identifier. Really? Did I not edit? I did not. Fascinating. Token type XOR. There we go. Yeah, this is Windows. And to make it extra hard, it is Windows and C without the C runtime library. So I'm essentially doing everything myself here. Because I like to make my life hard. Build run. Okay, cool. So we can run stuff. Well, that is excellent. It is a start. I mean, this invalid token will just drown out everything, right? So I'm probably gonna remove that at some point. But anyway, so we kind of have a more fine-grained tokenizer right now. So let's just commit that, right? Yep. Git commit. Of course, again, authentication failed. I really want to figure out why it's doing that on the first push after a while. I probably have misconfigured something, but oh well. Right. Okay, now we can sort of build what I actually wanted to do, build all the kind of parsing building blocks, right? So at the moment we just have parse source file and then like a bunch of stuff shoved in here, which, yeah, probably going to rewrite all of this because this is not really interesting. But I kind of want to start with like simpler building blocks, right? So for example, parse a hexadecimal value and actually just return a hexadecimal value, right? These kind of things. So make sure a string that's passed in is actually a valid string, right? And then from there, so if we encounter a symbol, we'll try to resolve that symbol, right? See if it is a constant somewhere. If it is not, then add it as a missing label and all this kind of stuff, right? And out of these building blocks, we can then go on and do something like build some more complex trees, right? So then you have to go into parse, for example, a binary operator, right? And this is the situation where you then have to look at the left and right leaf of it. And then operator precedence becomes like a thing, right? And then from that on, you can then sort of build all the way to a function that's just called parse operand, right? And then what is an instruction? Well, an instruction is basically just an instruction right here followed by one or more operands, or zero operands even, right? So you can then go from there. So basically we will start out at the most basic building block, which is like parsing this little thing here, or this, right? And then we go from there. So where do I have the math operations here? All right, this would be tiles and minus tiles, right? So I want to be able to parse this as well. So yeah, we'll probably be doing all our tests in the beginning of the file. I don't want to remove everything. I mean, probably can remove these. And the rest is kind of valid code, or should be valid code. But we'll get to that. Our tests will just be at the beginning of the file, right? So I open up the old assembler project, which was done in Visual Studio and with the C runtime, and my very first attempt at an assembler, and it sort of works. I just absolutely do not like what I did here, right? But some of the things like parsing numbers and stuff, I probably will just pluck out of that and try to modify like a little bit instead of like reinventing what I already did. Because I think those are kind of useful. So yeah. I think numbers is probably a good start. Uh, so yeah, let's start with immediate values, right? So what is an immediate? An immediate value can be any kind of number, right? It can either be 8-bit or 16-bit wide, depending on which instruction you use. But we'll probably just go with the biggest one by default, and then depending on what instructions we use, we can then verify whether it is, too wide or whatever. Or maybe we just truncate. I have not thought about it, and just spit out a warning or something. But in any way, what can it be? It can be a decimal, right? It can be a hexadecimal, or it can be a binary. But then also, like, it could also be a character, right? Because we can just plug in a character and that just you use the character as a valid value. I mean, an insane idea would be to also allow strings with 2 characters for 16-bit wide, right? But that would be kind of... I'm already questioning whether character was a good idea or not, but I mean, we have the ability to do that, so let's just add it in, right? So we have to have parsing for these things, for decimal, for hexadecimal, for binary, and for a character, right? Need to make sure those are correct. But then what it also could be is a constant, right? So, which is just like a long name of something. That could also be an immediate value. A decimal value could also be, well, so hang on. This is the first stage, right? It could be an constant, right? It could also be a label if we are dealing with addresses. Then a decimal could also be, like all kinds of operations, like a minus b, like arithmetic operations, right? Or a plus b, right? Or it could be a times b, or a divided by b, right? An a can be either one of these, right? One step before that, it could also just be minus a or minus b, right? Sorry, or plus a, like used as a prefix for a number. I guess really decimals can be signed or unsigned. Hexadecimal and binary I will always treat as unsigned. So a plus or minus prefix should not be allowed on these. Same for character. Right, and then obviously you can like chain all of these together, but that is like the very last stage for the operands. So you can also have parentheses around it, right? So you can like change precedence if you would want to, because that's another thing we'd have to deal with. It's like A plus times C plus D, right? Something like this, and precedence should be that this comes before the additions, right? Unless you change precedence like so, right? Then what would this be? Should this be reported as an error or not? So I have to think about these things. But we are right now at the very first stage, so the beginning stage right here. So just parsing these things, that is the very first step we're going to do. So in parser C, okay, what does a tokenizer actually hold? It holds the source file, the memory arena, the output binary, current token, and next token. Okay. Let's just start with parse binary. Right, and so we had this one. That was the old code on how to read binaries. Obviously, it's not going to be exactly the same, but parser check number separators. What the hell was that? Oh, right. Okay, well, a binary starts out with a token, right? I decided to use the dollar sign for, no, sorry, the percentage sign for a binary character, right? And everything that follows after it is part of the binary number. I mean, yeah, this is all nonsensical, but you get what I mean, right? So you would have, okay, let's be real, right? Something like this. This is our binary number. This would be a valid binary number. So would be something like this, right? You have like some separator characters in here. this would be invalid because, well, there is no binary numbers in there, right? Don't know what to do with it. This should be fine, right? It's just going to be 0 as a binary, which is fine. Really what this turns out to be is then something like this. That is fine. Invalid would be if we just have a separator. So we're starting out with a separator. That should be invalid. And probably if we end with a separator, that should maybe also be invalid. And then, of course, everything that is not, 0 or 1 is also invalid, right? So this is what this has been doing. It has been checking like the very first characters. So first of all, we want the token, right? Which will be the current token. So tokenizer, current token, right? Let's get the address of it. So this is our token. And we probably already have checked that this token is a binary token. So we don't need to do it here. But we can do a quick assert for the debugger, like if the token type is actually not what we're expecting, then we want to immediately start debugging it. So let's do an assert. Assert token type is binary. Holy shit. That sounds like hail. Damn. I have to walk my dog later on in this weather. Like, what the hell? I'm not sure if you can hear that, but that's horrible. We had like 19 degrees like 3 days ago or something. And now it's just abysmal. Yeah, that's not distracting at all. Okay, so the way the tokenizer reads those numbers, so if we look at the binary, right, we just read end of token and set the text length to something specific. The text length will include the first prefix here. Jesus. So we probably want to skip that one, right? So we definitely know we have a length of 1 at least, right? So if token text length so this probably okay, I just have to shout, I guess. Oi, I'm trying to stream. Shut up. This means we have an empty binary, most likely, right? Because it only contains the prefix, right? So this is why we would have a length of 1. We can then actually, instead of having the to-do there and trying to figure it out later, let's just put the errors in directly, right? I have something called add token error. we pass in the tokenizer, and then we can say empty binary value. Are we good now? No, it didn't stop. So something like this. Oh, I think it stopped. Thank God, that was horrible. Jeez. Okay, so we call parse binary, and if the length is only 1, it just means we have this one prefix right there, right? And then we're going to add a token error saying empty binary value, expected binary digits after token, and then print out just that one token, right? Which is of length 1. And then we just return out of this. The question is, where do I call tokenizer advance, right? So this is the thing that actually advances the token to the next token. So it sets the current token to the next token, sorry. Do I do these in these functions? Or do I do it outside of it? I don't know yet. Okay, if the length is anything else, we can actually say token text dot base. So the base now, the base pointer of this text actually points to the $sign, right? Which, sorry, to the percentage sign, which is the binary. I'm always on hex for some reason, but I don't know. We can just advance that by 1 now. And we can say token text length, right? Decrease that by 1. And then we have at least 1 digit, right? Because yeah. And this is where we can start parsing. So now we can figure out whether it actually starts with a separator character or it ends with a separator character, right? So if token text text base is this one, then we can add a specific error message for that. invalid binary value. A binary value may not start with a separator. Yep. And then if token text base is, actually we don't need that, but what I need is token text length -1. Now, if this one is a digit separator, right, then invalid binary value, a binary value may not end with a digit separator. So those are the preconditions. And then we can just go ahead and parse the text. So those were the preconditions. I'm not sure if I want to separate those preconditions out into do I want to do that? Nah, it's fine. Let's just leave it in there. It's not that much code. Okay, so what did I do here? I went through, checked for a 0 or a 1. Why I used hex values here, I don't know. Maybe I just wanted to make my life hard. Interestingly, I used 32-bit numbers. I wonder why. That makes no sense for the Game Boy, really. Oh, I think I know why I did this. So this was on the very first attempt for the assembler, right? And I thought, so I also allowed binaries, binary digits for addresses, right? And because, well, a Game Boy ROM can usually it's 32 kilobytes, right? And you have a 16-bit address space. But if you have like ROMs that exceed it because they're like 8 megabytes or whatever, I probably wanted to be able to specify an address like further down, so larger than 16-bit. And then I would have a separate pass over that to then fix those values and put them in the bank range. But I probably don't want to allow that. Yeah, I think I'm not going to do that. Okay, well, we have a character, right? And while actually no, let's just do a normal for loop for I think U32. You know what? I don't want to do these pointer manipulations right here. Let's do it this way. 1. And then here we go from 1 to right. And then our character is token text base I. So we have 0, or we have a 1, right? Or we have one of these. I don't know if I like this. Why can't it start with a separator? Let's think about this for a second. Like, why does it matter if I do this? Like, who cares? Genuinely. Or do this in the end. Yeah, I'm gonna remove that. That's like a restriction that I shouldn't care about. It doesn't matter, right? We just have the digits and we have this, and everything else will result in an error, right? So let's do the error first. What did I do in the old one? I just said invalid binary digit, right? And then just gave up. Okay. Okay, I also have to think about, like, I want to return something here, right? So this should be a value I can actually handle. So maybe I just make this a boolean and put the result down here. So something like U16, right? Result. And a B32. And then I can say B32 failure. Okay, so something like this. Invalid character, print the character. In binary value, print the whole binary value. Only 0, 1, or underscore are valid characters. Hey, thank you for the follow. Consecutive binary separators are not allowed. Yeah, I was very restrictive. I don't think I would do that again. I'm just gonna break and just ignore them. Right? And really, I just want to do stuff here when I have a 0 or I have a 1. And really, those cases are not that different. I do want to check the digits, I guess. That is one thing I should do. So fine. So digits, right? And if digits is bigger than 16, because we have 16 digits in total, then we can add an error message and return a failure, right? What was the old error message? Exceeded maximum amount of digits for a binary number. Okay. Exceeded maximum of digits in binary value, blah, blah, blah. Only 16 digits are allowed. Okay. And then here we just need to build up the value, right? And what we can do is just say, because we're setting result to 0, we can just say result equals whatever result has shifted by I never know the precedence of these. Oh my god. Shifted by 1. Right, and then we just say plus no, hang on. Didn't I do this for this? Yeah. So this minus this. Whatever we have, we shift by 1. We take the hexadecimal value from that one, subtract the hexadecimal value for 0 for it, and it will either be 0 or 1. There we go. No need for those 2 separate branches that do pretty much the same code. There we go. Simplified it a little bit. And then return B32 success. So the question for this still is, where do I want the tokenizer to advance? Right? I think maybe outside of these functions. But then I do have to remember to advance every single time, which is not great either, is it? Okay, add token error. What do I need the tokenizer for? The tokenizer is for the file name. Oh, and the current token. Right. If I would want to advance here, I would have to do it for every single return. Which is not something I want to do. So I'm doing it outside. Okay. Okay, so this is our parse binary. We can now try and figure out whether it works. We can go via case token type binary and say parse binary, right? If is success, right? We pass in the tokenizer and we want a result. So let's call it value, right? Value. And if success, we can just print it out for now. Wait, did I? What do I do for printing? Right, I have to call string format and then, right, okay. This is just for debugging purposes, right? So I'm going to remove that later on. But basically what we want is the tokenizer arena to use as a buffer. And then we just want to say parsed value is going to be this decimal right here. Hey Negvorsa, welcome back. That's going to be the value. And then, right, output string message. Okay, so now build. Fantastic. let's do some tests, right? So it now recognizes binary tokens, so we can just do where did I do the examples? Did I just remove them without copying them anywhere? I'm a genius. Okay, whatever. We can just do some examples, right? So let's do an error. So this is an error, right? This. Ooh, what are we doing in this case? Ha! Okay, okay. Well, we're counting the digits. If digits is 0, then add token error, tokenizer, you know what? We're just gonna be like this. And actually, we can remove this. Yeah. Okay. Then we have just 0. Let's just do 1. And then, I don't know. What about 42 in binary, right? With a separator. We can do 42 again with like longer separators. Uh, 1 0 1 0 1 0. Add some separators in the end, whatever. We can do 0 1 1 0 1 x 1 1 0 1. See what happens, right? We can do the same with 0 1 separator x separator 0 1. Right? Different tokens. So let's say someone would put a plus or a minus in here, right? What else? White space, right? Well, and then bigger than 16 digits, right? So let's just go. Yeah, like so. Yeah. You want to do with spaces? All right. That would just be a binary number of 1, 1 followed by a decimal of 10. Because white space is a separator. Same for here. This would report empty binary and then whatever this decimal is, right? But yeah. Okay. Build and run. Cool. Okay. This is annoying me. Hang on. Let's comment this out again. Build and run. Okay. There we go. Yes. Right. Oh, right. Yeah, because errors. Ah, man. Errors will be printed out at the very last moment, so this is why they're not in order, really. But we can just like, okay, so line 12, we have empty binary value, expected binary digits after token. Ew. Cool. So this works. Line 13, error, empty binary value, expected binary digits after token T, which is correct, right? Okay, then line 18 is this one right here. Invalid character X in binary value X . Oh, sorry. I removed lines. Of course, I'm no longer in the right lines. Okay. Let's be more careful here. 12, 13, 18. Right. Okay, that is correct. What it doesn't report is like... So the column is still column 1 on this error message. Because this is where the token starts, right? But really, maybe what we want to have is the column of that character right here. Yeah. Then line 19. Invalid character X in value . Okay, so this is also correctly reported, but again, need to fix error reporting here. Okay, line 20, empty binary value. Right. That is because plus is now a new token, so basically it breaks it up into these tokens, right? So we have a binary value, which is empty. We have a plus token, which we do not verify in any way yet or parse in any way. And then we have a decimal value, which we also do not parse at the moment. But this would report 3 different tokens, essentially. So that is okay. We just report an empty token. Not the best error message, but if someone looks at this, then, yeah, I don't know. I mean, we just say empty binary value, expected binary digits after token here, and if someone looks at their code and doesn't see like, oh, there's no binary digit, there's a plus, then you know how to fix it, right? So I think that is okay. 21. Empty binary value, yeah, same deal here. Line 22, empty binary value. Yeah, same deal here. We expect binary digits right after it, but there's white space there, so that is wrong. Line 23, exceeded maximum amount of digits in binary value. Only 16 digits are allowed. Right. Should I count the digits for the error message? Nah. That would waste time, right? And then we have line 24, which is not reported because this is valid and this is a decimal, which, you know, if I would uncomment like what I commented out here with the unrecognized token, this would print us like unrecognized token 10, right? But I disabled that for now. But we can now look at the parsed values. So we have parsed value 0, which is correct, right? Parsed value 1, which is correct. We have parsed value 42, which is correct. And we have the same 42 with all the separators there. Still correct. Then we have parsed value 3, which is this one right here, right? So that is correct. And then we have another bunch of parsed values, and I assume... yeah, there you go. Is that 128? Yeah, so this is this one, 128. Then 1. Yep, and then 129. And then we have another one, 228, somewhere in this code. There you go, which is probably this one. Yeah, 228. Like, it's just going to parse everything regardless, because we don't have any structure in there yet, right? So that's fine. But cool. So the parsed values actually do the right thing now. And now that value can be used in like some kind of tree or whatever as an operand value, or yeah, whatever. I haven't thought about that yet, but we have a way to read binary values. Now, fix error reporting for this. Okay. Let's do that. So, in parser, yeah. I probably need to add the error directly instead of with this shortcut to make that work. Oh, and then in exceeded maximum amount of digits. the column is for the binary value, but maybe it should have the column of where it exceeded it. I have to think about that one. Not dictionary, parser. Okay. This was really just a shortcut to get the current token, but I mean, yeah, that's not that bad. Right, I can put this in the next line. Like so. Okay, and the column is actually plus I, right? Column 7. So 1, 2, 3, 4, 5, 6, 7. Yep. And then by 210, yeah, we take your word for it, right? Actually, I'm going to check that in a second as well. Column 5. 1, 2, 3, 4, 5. Yes. Okay. And then byte. Let's do it this way. Nope. Right. How do you go to a specific byte? Wait. Okay, let's just 210. That is D2. D2. D0, 1, 2. X. Okay, cool. So that works. And then, I mean, we can check for here. Sorry. Hex 117. 117 right here, which is X. Okay. Yeah, but then here, I'm not sure. Anyone have any strong opinions in the chat, maybe, about the column? This is the column of the token of where the maximum amount of digits exceed, or should the column be the column of the character? No? All right. Yeah. I'll leave column 1 for now. Let's not get too fancy. Okay, cool. And then we can do sort of the same for hexadecimal, right? So go in here, parse hexadecimal. All right. We have the tokenizer and the result, still the same. We set that to null. We get the current token. We make sure that the token type is a hexadecimal, right? And then how many hex digits for this thing? It's like 2, right? Yes, 2. Sorry, 4. 4, 4, 4. Okay, so token type hexadecimal. The first character will be the $sign. So we can still do the same thing where we say, okay, we check for the digits at the end, and then we can say empty hexadecimal value, expected hexadecimal digits after token so-and-so, right? Okay. And then we do the same thing here, except, of course, with the 0 and 1. Let me just quickly check what I did in the old one. So we did read binary. I mean, I did this stuff here, which is all right. I see, because of character ranges, right? So, hang on. ASCII table. It's fascinating how it always finds a different homepage. So we have 3239, which is how I did this, 3239, or I mean, I can just do the same thing, really. U8 character is token text dot base I, right? And then if character minus 0 yeah, I did it up here as well. Okay. So this means we have a digit, right? Okay. And df. What is df? What? Huh? Oh, and df. Hang on. df. Yeah. I trying to figure out if I can combine those somehow, but maybe I shouldn't. Okay. So this is what I do on this one, and this is what I need to do on this one. And I can just yeah, so if it is not an underscore, we just sorry, if it is an underscore, we just loop through, right? If it is not an underscore, we do this check to see whether the value is from 0 to 9, right? And then add it to the output. This would be result. And if it is not that, then it is probably A to F, either uppercase or lowercase. And so result. And if it is not that, then it is an invalid character, right? So we're just going to do this. Which will be token line, token column, right? Invalid character C in hexadecimal value. Only okay. This can be character. And then we want to print out the whole value as well. Okay. After it was either one of these, I just count it as a valid new digit, right? And then if the digit is bigger than 4, then we're gonna do this. Come on. Exceeded maximum of digits in hexadecimal value. Only 4 digits are allowed. Just making a quick sanity check. But I think that's all right. Okay, so same with that. I mean, to be honest, we probably want to comment this out for now because this is not like how the final parsing works, right? This was just there as a test, but hexadecimal. Parse hexadecimal. Okay. Nope. Okay. So we have an empty one again. We have this, right? We have AB, CD. Why separate by the dot? Less than 0. Oh, I see what you mean. Good point. I think that should work fine because we're using unsigned. Should work. A, B, C, D, E, F, right? We have like a larger value. Oh, invalid characters. Lol. Let's just make an L, whatever. And then this should also just work fine. Okay. Build run. Ah, no. Ah, there's a shit ton of them. No, I forgot. Okay, well, let's look at the errors first, right? Line 12. Yes, empty hexadecimal value. Cool. Line 13. Yep. Then line 16, because this is valid and this is valid. Fantastic. 16. Exceeded amount of maximum digits. Ah. Wait. Hang on. Hang on. I mean, the next one is correct, yeah. And 18. What is happening here? Okay. So a few errors, but that's okay. Oh, because I'm manipulating it. Right. So really, we do want this. Okay. Invalid character L. Okay, so this now works. But this is concerning. The thing is, I kind of want to... You know what? I kind of want to see what's happening. I kind of want to see it. There we go. Right, and let's... move that to the very top. And... right, I need to change this to be in the right folder. actually. F11. There we go. So character B. Character dot. Really? Why is that turning negative anyways? Because... Is it because this is signed? Are you kidding me? Is this the only issue? Because character is unsigned, right? So if... Wait, am I still... No, I'm not. I mean, what I would expect here is like two unsigned numbers that you subtract from each other, right? An unsigned overflow would then make it larger than 10, right? So I'm a bit confused why it... There. But why, if I explicitly... No, but I'm explicitly casting it to unsigned here, right? So this is what I don't understand. Why it ignores this. You know? Do I have to be like... Is it you or something? Or is that only a thing for like... It just ignores my cast, right? If I do this, it just completely ignores my cast. But if I specifically say it's an unsigned... Huh. Sneaky. Little test. Okay. I should do this then. No, it doesn't matter for 0, but whatever. Amazing. Well, thank you for that, C. Didn't see that coming. No, like this is annoying, right? Because you specifically have a type that you say is unsigned. And it just completely ignores it. Like, that's why I wasn't worried about, like, this thing, because I just assumed, bad me, that, you know... Okay, I can understand this, right? Or this, that it then just does an unsigned minus a signed, right? And then, yeah, what do you prefer, signed or unsigned? Right, okay, I can get behind that. But if I specifically cast to an unsigned, right, and have this here, that it then goes ahead and ignores that, it's just bonkers. I'm wondering, is it because I'm doing it here and it tries to do something clever there? Nope. What first test do you mean? Well, I'm not assuming that. That's what this operation is for, right? To then figure out which range you have for, you know, A and F, basically. So A to F or A to F here. And then this subtraction basically gives it, well, it's either going to be 0 to 6, and then it is a hex digit, right? Anything else is invalid. I just didn't want to do this operation twice, really. But I mean, I could do that, but you could slightly rewrite it, I suppose, if you want to be more in line with this. Check at. Okay. There you go. If you want to see it in the debugger, let's do no, where's the locals? B, right, and then there we go, at. So this fails. Then you calculate the new character, right? It will be 255, because I guess it overflows. Which then character is larger than 6, and then you go to the error. I just am a bit shattered, I'm not gonna lie, about this signed to unsigned stuff. I hate when compilers do this, right? When you specifically you put in a hexadecimal value and you say specifically with a cast, it is unsigned, and then it just goes ahead and ignores it. Unless you put it like as a literal like this. That to me is just yeah. Okay, whatever. It is what it is. No worries. I like stepping through with the debugger because it helps me as well to like get a bit of understanding in it. Sometimes, you read the code and it's just like you can't quite parse it, so I just like stepping through it. It's a bit nicer. Helps me at least. Okay, anyways, so we have parse binary and parse hexadecimal, which is all cool, fine and dandy and whatnot, right? But then we also have parse decimal, right? So, and this one, this is going to be a bit annoying because I don't know how I want to deal with this. So let's say we have decimal can be signed or unsigned, right? So I can have a minus in front of it. But then if you have like arithmetic operations, you kind of have to, so if you have if you have a minus at the beginning, right, it's easy. This is a negative number, right? Okay, fine. But if you have it like so, then of course this becomes a math operation, right? So, and then this, again, this is the math operation, while this is the negative number, right? So I potentially have to deal with these prefixes right here outside of parsing the actual decimal value. So at the moment, we'll just treat every decimal as being unsigned, essentially, and just, you know, reading out the digits. Because I don't see another good way of handling that. And then once we go into this parsing of like all the operations, we can then figure out whether that negative value is actually valid or not, or like, yeah, I don't know. I have to think about it a bit more. But for now, let's just do. I mean, it is really simple, really. It's just doing the minus operation again, right? And then doing this little thing right here. So, Boop. Parse decimal. Decimal. Right, let's do dim. So the amount of digits here is a bit awkward, right? Yeah, it's unary, that word. I probably can't go by digits, to be honest. Oh, now we can, but I also want to check the overflow, right? So anyway, did I allow separators? Yeah, I did. Okay. So this minus this is smaller than 10, and we have something valid, right? Right, it's exactly the same exact base 10, right? There we go. and then else. Okay, so for decimal, I also like leading zeros is a bit awkward as well. Right, so something like this. Does that actually compile and see? Oh, it does. Nice. Do I care then? No, it's fine, but then the digits make no sense, right? Because like if I allow just like a bunch of zeros, like and then 1, 2, 3, then the number would just be 1, 2, 3 with all of this ignored. Like, I mean, okay. I can still count the digits, that is fine, but I think I remove the maximum amount of digits. I still check for invalid characters, which, yeah, that is fine. Just move this up, really, doesn't matter. But I could do something like this. And then what do those exceeded messages look like again? Should just copy this. No. Okay. So I'm still counting the digits for this part to don't have the separators. I still want to allow separators for whatever reason. I don't know. But if the value then exceeds U16 max, then we stop, right? So 42. I mean, right, this one right here. Right, this should still work. This should not. Oh. Oh, no. Wait, did I even... Come on, man. No, I didn't even use it yet. Oh, my lord. Okay. Decimal, right? U16 value, parse decimal. Okay. Build run. Wait, what? Hang on. I think I screwed something up tremendously. Okay. Okay. And then here, token type is decimal. Parse decimal. Maybe you should have an empty file. How about that? And just use these, right? Okay. Yep. Actually, it's clear. Okay. So that would be 0, right? What? What? Oh my lord. Ah. Dude, what the Right, I was ignoring still the first character because the other ones had prefixes. This one doesn't. And then empty decimal value doesn't make any sense either because that will... yeah, okay. So this actually cannot happen, right? Because even if there is a bunch of separators like so, that would just be recognized as an identifier token, right? Because that could also just be a name. So this essentially would just be a name. So there is no such thing as an empty decimal, right? It just doesn't exist. Right. So no need to do this. No need to do this. Right, no need for the digits. It has at least one number in there. Starts from 0, right? Cool. There we go. So this, whatever, right? Pass value 0. Perfect. 1, 2, 3. 1, 2, 3. Perfect. This is 42. Yeah, it just has a separator in there. Excellent. Line 5. Error. Invalid character X. In decimal value for X3. Bam. Okay, line 6. Invalid character X. Yeah, cool. Dot. Yeah, invalid character dots. Fantastic. Then we have the value 65535, which is the maximum for U16, right? And then we have one more, and then it will just be decimal exceeds maximum allowed value of this. So now, of course, you can also have numbers like this. Which, I mean, it works. Who cares? Right. If you want to write that, be my guest. Hey, thanks for the follow. Oh dear, I had a follow goal apparently. Well, thanks for finishing my follow goal. Hey. Okay. Okay, let's put all of this back. Remove these. Okay, so that is these parts done, right? We're not distinguishing between 8-bit and 16-bit yet. We just assume everything to be 16-bit for the time being, right? Okay, pass characters, I suppose. Characters in Game Boy, so in the Game Boy assembly language doesn't make any sense, right? What that basically means is just we're taking the ASCII value and taking that as the immediate value. So that is what a character would be. I'm not sure why you would ever want to do this, right? Just if you want to overly obfuscate your code, I don't know. But let's just do it. Let's just add it in. So that would be B32 pass character. Now that I do not have, in the old code. So this would just be a U8. Right? And I mean, okay, let's copy that and adjust whatever, doesn't matter. Result is 0. Tokenizes the current token. We want to make sure we have a character. And then, well, we have to take a look at the character, right? So, actually, I'm not sure why I copied all of this, but whatever. So a character, again, we either can have just one of these ticks, right? We can have 2 of these, right? This would be empty, which we can just use that as 0, as the 0 character, I suppose. Not as the 0 character, but as the hex value 0. While this would be an error. We could have something like this, which would be an error. We can have something like this, which would be valid, right? So maybe error 0, error, whatever the hex value of A is, right? So valid. We could have a slash, right? Followed by this. That will be an error because it's not closed. And or we could have this, right? Which would be valid. That would be the character, this one. And we know that the first character is always this tick because, you know, that's how we tokenize it, right? That's how we even find that token. So if token so this would be an error, right? Then whenever we only have 2 characters, it could either be a 0 or an error, right? And with everything else, well, let me just check the token parsing again. Ah. Okay, and here I basically have to check the last character and the character that's in there, right? So from there on, we have to do a bit of extra work, I suppose. No, I might do it differently. Hang on. Let's make a for loop. Okay, so if we are not in this range, then we do not accept these values, right? That is an error. Invalid ASCII character C in maybe do it as hex. Why just ASCII? So I don't have the code point necessarily. I have UTF-8 encoded strings, right? And You want to draw a border. Okay, remember this is for the Game Boy, right? This is an assembler for the Game Boy. And a character in the Game Boy just means nothing, really, right? I just wanted to have the ability to add ASCII characters and just get the hex value out of it, if you're so inclined, if you want to do something like that. The reason for that really is just because there is some ASCII values that the Game Boy header allows, right? So it has like a specific range. Which is actually the same range here. So that's why I wanted to allow that. And I don't want to go all this way down into the rabbit hole of like, oh, but what if I allowed co-points that are actually up to U16? And then it's just, I don't know, it makes the code a bit more unreadable, I suppose. And there's a lot of cases I would have to think about. So really, where is the gbdev.io? There is cartridge header. Well, it only uses uppercase ASCII. Ugh. Okay, this is where it starts again. Wait, where's the entire range? You'd think I remember because I made a video about this. I'm watching my own video. Whatever. I have the table right there. There you go. So this is the only valid ASCII range for Game Boy headers, really. And I could limit it to just that, but I don't know. The more I think about it, the more I don't like the idea of having the ASCII character in there like that. I might actually remove that token altogether. So the only reason why I wanted this in there is, for example, if you want to load into register A the value of, I don't know, XA, right? Then this would be translated into like LDA whatever the hex code for A is. Well, isn't it 61 or something? Because it's, let's say uppercase, right? 41. So that would be the equivalent of that. But the more I think about this, I don't really know when you would ever want to do this instead of just writing the value that you actually need. Because really, when you do the Game Boy stuff, you don't really think in terms of characters, because that's just not a thing, right? All the graphics and stuff are also just like individual bit pixels, right? That's really what you care about. So yeah, the tiles, exactly. And I was thinking, okay, maybe if we have something like, the header section, if we want to set the Game Boy title, we could do something like, let's say it is some kind of data, right? And the title goes there. You want to write something like something like this, right? And then 0. In some assemblers, you might actually have to do this, right? If you use like a generalized assembler, because they don't know anything about Game Boy headers and things like that. But I'm trying to build an assembler directly for the Game Boy. So what I would do instead is, and you can see that down here, is I have a command for like header title, right? And then you can just use a string and just type in Tetris. You should also spell it right. And that would then do the right thing and place it in the exact area in the memory location that is needed for that ROM file where you put the header in, right? So there's no need for this kind of stuff. I'll think I just keep it simple and remove that for now. Hang on. I should do this in a separate commit, right? Yeah, I don't want to deal with pass character for now. That is it. Okay, build run, right? Okay, so it still builds. That is awesome. Get status. Okay, I removed that stuff. That is okay. Oh my god. Again, the authentication error. Okay. Okay, let's move that. read end of character, whatever. The flashing of the first generated code, yeah, that would be awesome if we could already go there, but not quite yet. But yeah, would be amazing. So with the old assembler that I had, I could at least already do the Hello World and stuff, but I have actually not flashed it. I've only run it in the emulator. But I do have a flash card now, so which is good. So I could actually try it on all those Game Boys back there. There you go. Right. I have been streaming for 4.5 hours. I'll probably gonna stop soon. Yeah. So, hang on. Game Boy Color, the Game Boy Light, which was only available in Japan, the Game Boy Pocket, the original Game Boy, and this one is the Analog NT, which is like an FPGA Game Boy kind of thing. And then down there is the, what's it called? I forgot the name already. Has nothing to do with the Game Boy. Sorry. It's the little handheld from Panic. Oh God, what is it called? My brain, dude. Playdate. There you go. This one. Which I would love to write some stuff at some point as well for this, but yeah. Oh, and then of course, in the Super Nintendo here is the Super Game Boy, but I am missing the Super Game Boy 2, which also only available in Japan. I could get it from eBay somewhere, but yeah, I have not yet. Okay, I'm trying to figure out how I would put this together, you know. I mean, of course, what we can have now is we can have a B32 and say parse number, right? But that's not actually a thing that would happen in the parsing, right? really what we would have is something like pass operand, right? And then that operand could be whatever. What do I need the tokenizer for in here? This is only for token errors to get the current token. But we could just pass in the token and add the error like that. And then the only thing that it really needs is like the file name for error messages, right? And I also need to be able to deal with constants and labels. Right? Labels would be addresses and constants can be anything. And right. That's also like something a little bit annoying. Because let's say this, for example, right? So here you're looking for an address, right? So a 16-bit address. And what you're getting here is labels, right? And you're trying to subtract the labels from each other, the addresses of those labels. But those labels are only defined all the way down here. My dog is going nuts at the moment. Great. Oh, food. Nice. Okay, I'll stop in like 5 minutes. I'll stop. All right. The magic food fairy arrived. So I actually have food. Hey, you. Hello. you want to come out? All right. Is that why you barked? Because someone came with food? Huh? All right. Okay. Yep. All right. I'll leave it here then. Like I said, I cannot stream this Wednesday because I'm gonna be out of town. But I'll probably make up for it on Saturday, maybe. Yeah, I can maybe do Saturday. We'll see. And on the next stream, I'm gonna be tackling these things here. So, I already closed. No. These things. So constants and labels, right? Trying to pass those, and then these operations right here, and try to build like a tree out of it. I can't read. Oh my god, what's going on? All right, okay, yeah, it's all right. Okay, thank you. Yeah, so that's what I'm gonna tackle on next stream. That's it. If you guys have any questions, last minute questions, I'll be happy to answer. Thanks for the stream. No worries. Good stream. Thank you. Are you hungry as well? You hungry as well? All right. Go over here. I'll be done in a sec. All good? Thumbs up? All right. Excellent. Well, Dog Boss has spoken. Oh yeah, absolutely. She is my boss for sure. All right, cool. Well, thank you guys for watching. Have a great rest of the day, and see you next time. Bye.